Just a request to the organizers, if we can start in 2 minutes, it'll be good, because I have another meeting at 8 and I want to maximize my time here with you so that we can do the full hour and Q&A. So if it's possible, maybe we can start in a couple of minutes. Yeah, great, thanks.
Can you hear me? Can you hear me?
Yes.
Okay. So I'll just start. Good evening, everyone. I'm Niranjan Iyer, and on behalf of the PICT ACM student chapter, I extend a warm welcome to this Eminent Speaker Program. The Eminent Speaker Program, an initiative by ACM, connects students with globally renowned experts who share insights into groundbreaking research and advancements in computing. It is designed to inspire innovation and also foster a deep understanding of the challenges and the opportunities in the field. PICT ACM student chapter, since its establishment in 2011, has grown into a vibrant community of over 400 members. We have achieved several milestones, including 5 Outstanding ACM Student Chapter Awards and the Outstanding Chapter Website Award in 2023. It is my pleasure to introduce today's speaker, Dr. Viraj Kumar, a visiting professor at IISc Bangalore. Dr. Kumar is a leading educator and researcher in computer science education and technology-enhanced learning. He has a rich academic background with degrees from St. Stephen's College, IIT Bombay, and the University of Illinois at Urbana-Champaign, where he also completed his PhD. Dr. Kumar has contributed significantly to areas such as computational thinking, interactive teaching tools, and educational technologies for undeserved communities. He is currently the Vice Chair of the ACM India Special Interest Group on Computer Science Education and has co-chaired major conferences like ACM Compute and IEEE T4E. Today, Dr. Kumar will discuss helping students develop the ability to critique AI-generated code. In the era of generative AI, it is essential to equip students with the skills to evaluate and improve AI-generated solutions. Dr. Kumar will provide valuable insights into this critical aspect of computer science education. Without further ado, I now invite Dr. Viraj Kumar to share his expertise and perspectives with us.
Thank you so much, Niranjan. Very kind of you for that introduction. I hope I'm clearly audible. Can you hear me clearly? Excellent. Okay. Okay. What I might do is I might have to keep my video off in case the bandwidth suffers, but at least to say a quick hello. And it's very nice to re-engage with PICT. I've been to your lovely campus. I've, of course, interacted with your award-winning chapter at various ACM student chapter events. And, of course, Professor Gitanjali and others are very valued colleagues within the ACM India community. So very nice to receive your invitation, and I hope I can make this worth your while. Thank you for spending some of your evening hearing me out. So I don't have prepared slides. I thought what I would do is I would keep this very interactive. I hope you can see my Visual Studio Code editor. I have got GitHub Copilot installed. I'm sure many of you have explored tools like this, perhaps Copilot itself. And I think at this day and age, everybody needs to get at least awareness of how good or limiting AI code generation is, because by the time you graduate, which is not going to be very far from now, you're going to enter a world where such tools are going to be in use to a greater or lesser extent, right? So I'm going to make some assumptions here. Someone can please quickly correct me if I'm wrong about these assumptions. I'm assuming that our audience, our students are all fairly familiar with both C and Python, just basic stuff. I'm not going to be doing something very advanced. Can I just get a quick confirmation that both C and Python are okay? People are generally comfortable with C and Python? Yeah. Okay. I'm taking that raise hand as yes. Okay. Excellent. Oh, I'm seeing some thumbs up as well. Excellent. Okay. All right. So let's start with writing a little Python function. Okay. This Python function, I give you an integer n, and I want to count how many digits it has, right? So we'll give this function a sensible name like num digits, right? And you saw as I was typing, my AI is jumping in and it is making a suggestion, right? So it is making a suggestion that, and by the way, it's suggesting that I use what are called type hints, right? It's saying I use n of the type int, right? As you know, in Python, Python is dynamically typed. You don't have to specify the type of the argument n. But my AI is being sensible here. It's saying, in the real world, companies increasingly try to use type hinting for their Python code. And if you're curious why, you should look this up. And if you yourself don't use type hinting for your Python code, a very good habit I can suggest for you is to get comfortable with using type hinting. By the way, if you do use type hinting, not only could your potential employers be impressed, but your AI will better understand what you're trying to do. Okay, so my AI is suggesting, I'm just going to press tab to accept this AI generated suggestion. It's saying, okay, n is of the type integer, and by the way, this function is going to return an integer as well, right? And it says return length of str of n, which is a cute Python way of calculating the number of digits, right? So I take n, I convert it into a string, right? And I count how many letters that string has. That, of course, will be the number of digits, right? So you see how incredibly easy it is to use AI-generated code, right? Well, there's a problem. This function is wrong. Can you see why it is wrong? Can someone in the chat message and tell us, why is this seemingly cute, seemingly obviously correct function actually incorrect? So I want you to stare at this for a second. And I can't really see the chat, so someone can alert me if there is a message on the chat. Maybe I can request the moderator to read out the message if anyone types a message on the chat. So why does this function not work? I hope the syntax is not a problem for anyone. Just in case it is, I'm going to just repeat how the function works. So the function num digits is supposed to count how many digits there are in the number. If I give you the number 121, that has 3 digits, 121, right? So 3 digits. So I give you the number n. The first thing this does is converts n to a string, right? So it would take the 121 and it would convert that into the string 121, and then it would say that string has length 3. By the way, my AI is even completing my thought process for me in this weird line over here. It's saying, okay, so that's how it works. 121 will have length 3. Actually, a better way of doing this is to put it this way. Put it in a what's called a doc string, and within the doc string you can write a doc test, right? So it's suggesting num digits of 123, and number digits of 1, 2, 3 is 3, and similarly 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, that has 10 digits, and so on, right? So that's how the function is supposed to work. How does it actually work? As I said, it just converts n into a string and tells you the length of that string. So it seems correct, and it's wrong. Why is it wrong? Yes, someone has their hand up. Yes, Raj, would you like to, perhaps if the moderator can unmute Yes, Raj, you can hear.
Yes, sir. Good evening, sir.
Good evening. Hanji, bolo.
So I think we've the return length of string, that is the number of digits. So if we
Hanji.
introduce a negative sign in the number that we've
Very good.
I think it will return the negative sign as a digit as well.
Absolutely, right? I mean, as I said, if I do 121 goes to the string 121, which goes to 3, right? What will minus 121 do, right? Well, you see, the AI is thinking and says it's going to go to 4. But of course, minus 121 only has 3 digits, right? So very good. That's exactly correct, right? So let's see if we can prompt our AI to think of negative numbers too, right? So let's give it minus 121, right? And it recognizes it's got 3 digits, right? So now let's see if we can produce the correct code. You see? Now it's taken absolute value, right? So if we are not careful with exactly how we prompt it, our AI might produce incorrect code. Now, for simple problems, it almost always produces correct code. I keep this example as my hello world every time I'm testing generative AI code, because I've seen so many code generation tools mess this up. Interesting question. Why do these sophisticated code generation tools mess up something so simple? And I don't work at these companies like GitHub and the underlying models developed by OpenAI, but I have a suspicion that a significant part of the reason is that these things have been trained on badly written code. So, they're working very hard to try to improve the quality of their training data. But this particular function, num digits, is so commonly asked in introductory programming everywhere. And there's probably a lot of people who've written this code without thinking of negative numbers. Right? All of us, when we're beginners, we forget about these kinds of corner cases. Okay, so it's been trained, I suspect, on lots of examples where it's essentially length of string of n, and that code is incorrect, and now the AI is struggling to forget that bad example. You see examples of this in other cases. For example, if you ask it for, now in this case, this is not an incorrect code, right? If I say is prime, right, which is again a very standard problem, right? N of the type int, right? It's going to, I want it to return either true or false, right? So I'll say return bool, and it's producing this code, right? You are probably familiar that this is a clever optimization. If you want to search for a factor of n, you only have to search up to about root of n, right? And so int of n raised to the power 0.5 plus 1, because we're doing range, this will produce the right approximation to square root of n. And so this is one way of sort of solving this problem. This is more efficient than the most naive way of solving it, which is, like maybe trying every factor or every second factor. But this is still not very efficient. Okay, and there are well-known solutions that are much more efficient than this. There are much more efficient practical algorithms that are randomized, that are far faster at determining if a number is prime. People know about them, but so much is prime code is written like this that the AI is somehow unable to forget that. Okay, so what, not so much this example, but our previous example shows us is that AI generated code can sometimes be incorrect. And that is the premise of my talk, right? That I don't want you to feel, oh, AI has produced the code, it must be right. I wanted to give this demo to you to show you that AI generated code can look correct, right? It looks so cute. It looks right? It took us a while to sort of figure out why it was failing. So the mistakes can be very subtle. So what I do at IISc, I tell my students on day one of their first year programming course, I say, there is this thing called Copilot. There is this thing called ChatGPT. I mean, they all know about these things anyway. They don't need me to tell them. But I give them examples of non-trivial problems that these things can solve. And I tell them, I said, in this course, if I give you a programming problem, you can use any of these tools. You are completely free. I want my students to be very comfortable with understanding how good these tools are and where their limitations are. But the skill I want my students to develop is not the skill of typing and putting the semicolon in the right place and the comma and the closing bracket and the colon and the indentation. All that is syntax. And before generative AI, it took students a huge amount of effort. I'm sure you remember this. Took a huge effort learning how to write correct syntax. And the point is that these generative AI tools make it very simple to generate syntax. I mean, they very rarely produce syntax errors. Very rarely they produce syntax errors. So it's easy to write code. The hard thing is to confirm if the code is correct, to develop this ability to critique, to critically analyze AI-generated code. So what I do is I develop this ability. So now I'm going to show you some examples of problems that are aimed at developing this ability to critique code. All the examples I'm going to show you now are not AI-generated code, right? Because as I said, for the kinds of simple problems that I introduce my students to, the AI-generated code is almost always perfectly correct. So it's very rare that I have these examples where it's making mistakes. But I do want my students to look at some code and say, oh, even if it looks right, it might be wrong. Can I find the mistake? So that's what we're going to do now. We're going to take a look at some problems, simple problems. And I promise you that every one of the pieces of code that I'm going to show you is buggy. It's wrong. Okay, it's going to be syntactically correct. I'm not, unless I made some silly error while writing it. There should not be any syntax errors. Okay, so let's share my screen. While I'm doing that, would anyone like to ask a question? I noticed there's lots of answers on the chat. I'll just quickly mention. So Mayank had mentioned as a possible problem with the count digits was, I think 11 will be counted as 2 digits, right? So this was, Mayank, is an excellent point, right? That it wasn't very clear when I said count the number of digits. Did I want to count the number of unique digits or not, right? I think by the time I gave the example of 121, it was after Mayank would have posted. And in 121, I said that there are 3 digits. So then Mayank would have figured out, okay, so he doesn't want to count unique digits, right? But it's a very valid question that Mayank has posed, okay? Ajinkya was suggesting that the data type is int and you're returning it as a string. Ajinkya, you have to be careful. If you remember, I was converting it to a string, but then I was calculating the length of that string. So I was making it an int. Once again, I'm sure you figured that out afterwards after thinking about it. But again, good that you wrote it, because if you had that doubt, probably other people had the doubt as well. So excellent. Good that you put it, right? Okay, any other doubts you can mention in the chat while I'm setting up my window. Okay, I don't see anything immediate on the chat. The organizers, please let me know if there's something on the chat, right? I hope you can see my screen. This is some C code. This is a median function, right? So in every problem, I'll focus on a single function. This function is supposed to calculate the median of 3 integers a, b, and c. Can someone tell me why this function is wrong? More precisely, I would like you to give me values of A, B, and C that I can type into the main function. And then tell me what the median function should actually return, right? We will call the median function on your A, B, and C, okay? We will assert that its value is whatever you tell me it's supposed to return, right? And we'll see if this assert statement is actually true or false, right? So the way an assert statement works, I hope you're familiar with it. You put some Boolean condition inside this. And if this Boolean condition is true, nothing will happen. Your code will proceed normally and we will safely return 0, indicating that there's no problem. On the other hand, if this Boolean condition is false, our code will crash and we'll get an error message at that line. And we'll know that the function is buggy because we would have found some values of A, B, and C for which the median function produces a wrong answer, right? So take a look at this median function. And in the chat, why don't you suggest some values of A, B, and C, and then also tell me what the median of those values should be. I hope you remember what median is. If not, quickly Google it, and then tell me, right? Okay, so Niranjan is suggesting a way to fix the code, perhaps. Okay, so Niranjan, I hope I haven't made any syntax errors. Right. In fact, we can try this. We can click on this visualize execution. And if there are no horrible red marks, then OK, so the code is ready to visualize, etc. So there are no syntax errors over here. OK, so we don't necessarily have to put an else. Maybe since you've mentioned it, I'll just briefly mention. Remember, if you have an if condition with a return statement, then the only way to get to the next line is actually in the else case, right? So whether I put an else over here or I don't put an else over here, it means the same thing, because the only way to get to line 6 is if the return on line 5 did not happen. And the only way the return on line 5 did not happen is if the if condition on line 4 was false, right? That means I'm coming to line 6 in the else case. I hope that made sense. Okay, I said it quite quickly, but I hope it was clear. Okay, so there are no syntax errors, but how would we, can someone give me values of A, B, and C for which this code fails? Okay, Ayush is asking an interesting question, right? What if C is less than equal to B less than equal to A? So Ayush has recognized that, there are 3 factorial permutations of A, B, and C. Ayush can see A less than B less than C, A less than equal to B less than equal to C, and Ayush can see B less than equal to A less than equal to C, right? And he very rightly can't see C less than equal to B less than equal to A, right? And if C is less than equal to B less than equal to A, then the answer should be B, right? Because B is the number that is in the middle, right? And if it's not this case, and if it's not this case, then this code is returning C. So Ayush has sort of figured it out. So let's just take some concrete values that will make Ayush's inputs true, right? So let's say C is very small, B is the middle number, and A is very big, right? So C is very small, let's say C is 1, B is the middle number, and A is very big, right? And the median of the numbers 3, 2, and 1 should obviously be 2. 2 is the middle of those numbers, right? So let's verify if this works. Okay. This is Python Tutor. I don't know if you've used Python Tutor. I hope you have. It's a very nice way of visualizing the code, right? The execution of the code. So let's see what happens. We start with main. We initialize. This is happening. This rather ugly thing is happening because of the assert statement. So anyway, A is initialized to 3. So you see 3 over here on the right. And then B is initialized to 2. And then C is initialized to 1. And now we call the median function. Right? The median function, we pass the arguments by value, right? So those 3 values, 3, 2, and 1 get copied over here. Okay. We now check if this condition is true, right? Well, because of the way we chose the numbers, this if condition is not true. right? So we're expecting this red arrow, which is telling us which line is going to happen next. We're expecting the red arrow to jump to line 6. So we press enter, and notice we actually go into line 5. So according to this, this condition is true. A less than equal to B less than equal to C is true. How is this happening? This is going to return B. B is the correct answer too. And so this assert statement is correct, and there's no error. How did, on these inputs, how did we get into this if condition? How is this if condition even true? This talk is full of mysteries. I hope you're finding it interesting. A is 3, B is 2, C is 1. How is this if condition true? I'll give you a clue. Okay, Vijay has got it, right? Well, Ayush has also got it. Vijay has pointed out the problem with the given code, right? So take a look at the statements on the chat. The code that we have written over here is syntactically correct C code, but it is not semantically correct. It doesn't have the right meaning, right? In fact, if you compile this code with any decent compiler, right, you will get a warning message, right? Something like this, right? That, hey, when you write comparisons like x less than equal to y less than equal to z, they don't have their mathematical meaning, right? So if you really wanted to do that, you have to use additional operators, right? So if you're interested, you can explore this piece of code. What I will do is Python Tutor has this very nice feature where you can generate a link to this code. I will take this code, I will paste it on the chat. It's a very, very long link. I hope it pastes accurately. I believe it has. You can click this link and try it out yourself, right? And you can fix the code the way your friends have suggested. And then the suggestion that was given would work. Okay, so here I just wanted to give you this example where actually the code is wrong. It has a logical error, but it's a little bit tricky because this is actually not the right way of writing it. Now here is the equivalent Python code, right? And in Python, it's perfectly okay to write this kind of thing without, the AND operator. Okay, so this is fine. And in this case, our suggestion of A equal to 3, B equal to 2, C equal to 1, where the median of these is 2, this will fail. Okay, so let's try this out. Because this is where that missing, you see, there's a red arrow, red thing over here, and it says assertion error. This statement is not true, right? And if we back up a little bit, we'll find that this function is returning 1, right? Why is it returning 1? Well, because of the way we constructed the input, right? We constructed the input so that C was the smallest. So this condition is not true. Since C is the smallest, this condition is not true. And we come over here and we return C, which is the smallest. It's not the median, right? And that's why this will fail. Okay. So I give my students a whole bunch of problems like this. I do give them some programming tasks as well, but this skill, the ability to critically analyze a given piece of code is, I think, a very important skill, particularly now in the Gen AI era, right? Now, I've been thinking about these problems for a while. I call these problems refute problems. I started thinking about them I wrote this, I submitted it as a paper. It didn't get accepted as a paper to this top conference called IISc, but they very nicely accepted it as a poster. So I said, chalo, at least it's out there. Somebody will look at it and maybe people will read it. Not very successful so far, but I put it out there. Okay. I then started talking about this to other colleagues as well, and we've developed this idea substantially. So more recently, especially now when generative AI models came out, we have written another paper where we have taken this idea a little bit more seriously now that Gen AI is there, right? And we're saying we have to find a way to make these problems easy to create for faculty so that students can get lots of practice, right? And the basic idea of this paper, which was written with colleagues at BITS and at IIT Kanpur, the basic idea of this is, where can we find good refute problems, right? Where can we find problems that look right, but actually they're not right? And the very natural answer was, let's go back to earlier semesters where we had given students code writing problems, and we know that the submitted code is buggy, right? That means some student actually thought that code was correct. That's why she or he submitted that code. Okay, but we now know the code is buggy, so maybe we can recycle that buggy code as a refute problem, and that's why we called our paper "A Bug's New Life." Right? We took this bug and we gave it a new life in this form. Okay, so that's what we're going to do. Okay, so I'm going to now. In the rest of the time, I'm going to give you a series of such problems to actually try out, right? So far we've been sort of looking at it. I'm asking you to think about it right in the chat. I actually want you all to try it out, right? So what I'm going to do is I'm going to give you some links from a website called CodeCheck. I have created a whole bunch of such problems. So in the chat, I'm going to paste now the first problem one, the link to problem one. Please take a look at the link on problem one. When you open it, you should see this code. I will now walk you through how you can actually solve this problem. So I give this to my students in the lab. They work on such problems, right? Now you can't edit this code, so this is not a debugging exercise. The function is buggy, but the student just has to tell me three things. Give me a string S, tell me what value was returned on this input S by this buggy function, and tell me what should have been returned. Okay, so as an example, suppose I say, okay, ABC, the string ABC. Okay, well, this function is supposed to count the number of vowels, right? So the value is 1. I think this function should return 1. You can double check. Of course, the expected answer is also 1. Okay, so I put in the input to the function. I put in the value that the function actually computes on that input, and then I put the value that the function should have computed if it was correct. Right? So that would be the expected result, right? Now I click on code check and I'm trying to refute or show that this code is buggy, right? And I get a score 2 out of 4. The reason I'm getting the score 2 out of 4 is that, I'm not actually refuting the code. I mean, it's producing, I'm saying it has a return value of 1. And the expected value is also 1. That means the code is working perfectly fine on this input ABC. Okay. So by playing around with S and then this return value and then the expected value, please try and see if you can make your score 4 out of 4.
Excuse me, sir. There is a message in the chat.
Yes, please go ahead.
By Vijay.
Yes, I saw that. Thank you. Yeah, I can see it. Yeah, the code is case sensitive. You can lower the case before checking. Very good. Now, once again, Vijay and other students before him, and also my students, right? When I give them these problems, they're very eager to fix the code. And to solve this problem, I don't want you to fix the code. I want you to prove that it is incorrect. Then once we're all convinced that it is incorrect, we can go ahead and fix the code, maybe in the way Vijay suggested, or maybe in some other way. But I know the tendency, the eagerness is, I can see where the problem is. I'm immediately rushing to fix it. But first focus on proving, convince everybody that the code is actually incorrect. Give me inputs on which the code fails. Okay, in this case, give me a string and tell me what the function actually does on that input, and tell me what the function should have done on that input. So very good. So Vijay has taken his idea and said, okay, since I can see the problem is with uppercase letters, I'm going to try it with ABC with a capital A, right? The return value of this buggy function is actually going to be 0 because it's very clear from line 7 that this function only cares about lowercase vowels. It doesn't even consider uppercase vowels, right? So Vijay had sort of quickly figured that out, and we can all sort of very carefully run this code in our head to see that if I give you capital A, B, C, then none of the letters of the string will be in little a, little e, little I, little o, or little u. So the answer will be 0, right? This result is initialized to 0. And only if I find vowel in S, then do I increase the result by 1, right? So I don't find A in S, I don't find E in S, and so on. So the result will be 0, but the expected answer is 1. Okay. So let's see if this is correct. And yes, we get a score 4 out of 4. Okay. There was another suggestion. There was another suggestion from Vedant, right? And I think this is also what Niranjan is saying, right? So this is another type of counterexample, right? So let's see. So what Vedanta is suggesting is a concrete counterexample, right? AA, BB, CC, right? All lowercase, right? Here it's not, we're not taking advantage of the uppercase, lowercase difference, but AA, BB, CC, if you read carefully what the function is supposed to do, it's supposed to count the number of letters of S that are vowels. Okay, so how many letters in this string are vowels, right? The expected answer has to be 2 because 2 of the letters are vowels. But as was very rightly pointed out by Vedant in the chat, right? The code is incorrect. It's iterating over the vowels, right? This loop is starting at I equal to 0, I less than length of vowels, right? It should actually be iterating over the letters of the string. Okay, so what this code will actually do is count, does the string have an A, does the string have an E, and so on. And it only has an A, so it will only count 1 for the A. Okay, so this is also a counterexample, a very different type of counterexample. So the given code is buggy, is badly buggy. Okay, and once again, I'm not saying that if you give this kind of prompt to right, but I'm developing my students' ability to doubt code, right? So some of you are immediately looking at going, I can see what's wrong, I can see what's wrong. That's great. Now, all I want you to do is carry on that approach next time you see AI generating code, right? Again, the worst mistake you can make is, oh, AI has produced the code. Oh, it's this powerful GPT 500 model or whatever it is, whatever the latest, greatest model is. I don't want you to have that kind of a rishta, that kind of an equation with AI, because this current AI technology, this current LLM-based, transformer-based technology hallucinates all the time. And so you cannot be sure that the code is correct. Okay, now if it's a very, very standard problem, like prime or something like that, there's a really good chance that it's going to be correct. It's not going to make a mistake on that, because there it's just parroting some pre-existing solution. Okay, but in general, you have to be super, super careful. Okay, so since we discovered both these errors in this one example, you should very quickly be able to try this one yourself. Okay, I'll give this to you. In some sense, this should be easier. Try this, please. And if anyone is struggling with the interface and interpreting what's going on, please do ask. So it's the same problem, just a different buggy solution. So let me know if you can refute this one. Yeah. Kanesha has got an excellent counterexample, similar to something that we did earlier, right? If there's a repeated vowel, once again, this is iterating over the vowels, not over the letters of the string, right? So this will work, right? Very good. Okay, now let me give you a harder one. There was an earlier comment that people are more comfortable in C. So let me give you a C, this function, right? This says at the top it says CPP, but it's really just a C function, right? I haven't used any fancy C++ here. So let's try problem 3, this link. Okay. So this is given an array of integers, and you're supposed to count the number of unique integers in the array. Okay. This one is a little bit more challenging. So give yourself time, read the code carefully. And once again, here there are 2 arguments to the function, an array and its length. You tell me what the expected answer is. You tell me what the actual incorrect answer is, right? And then check your code. While the students are thinking, I don't know if there are any faculty in the audience. I think it would be good for you to consider introducing such problems to give your students practice with this. If you have any questions from the faculty side, please do ask while the students are working. Okay, so this code is as I said, quite a bit harder. doubly nested loop and things like that. I hope the problem is very clear, right? So someone gives me an array of length n for all I, for all j, some conditions, some breaking, some counting, and it's a complicated logic, right? This code may not have been the way you write it, but somebody has written this. And you have to firstly disprove it. Then we can worry about fixing it. Okay, so Shardul has suggested something. Shardul, if I may request you, I'm going to take your input, but could you also please type what the expected answer is and the actual buggy result that this function produces, right? Maybe the expected answer is quite obvious from the input. So maybe if you can just type in also what the incorrect answer returned by this function is on your input. So I will, in the meantime, copy your input. Okay, thank you. So the expected answer is 5. So let's copy this. Okay, somehow it's not copying properly. So let's say 1, 2, 3, 1, 3, 4, 5. 1, 2, 3, 1, 3, 4, 5. So that's an array of length 7. The expected answer is 5 because there's only 1, 2, 3, 4, 5. But what this function returns is also 5. Well, if this function also returns 5, then Shardul, we haven't actually shown that the code is buggy. We've just found an input on which the code is working, right? We haven't refuted it, right? And it's actually telling us that I have a wrong return value 5. It's giving me a score 3 out of 4, saying you're almost there. If you just tell me what the actual return value is, it's not 5. The buggy function doesn't return 5. But if you tell me what the actual return value is, you will have found a counterexample. Okay. So Ayush has suggested a different input. Again, Ayush, I would like you to try and think about what the expected answer to Ayush's input is. Obviously 3, because there are 3 distinct numbers, 1, 2, and 3. But what is the incorrect answer that this function actually returns on Ayush's input? So we have 2 suggestions, Shardul's and Ayush's. We can go with either one. First, we need to know what is the incorrect answer. Okay, so Ayush has proposed something. So let's try Ayush's. 1, 1, 1, 1, 2, 3. So that is 5. The expected answer is 3. And Ayush is suggesting that the return value is 2. Okay, that this function actually returns 2. Okay. And we get success, 4 out of 4. Okay. So very good. Okay. Now, you notice in Ayush's solution and in Shardul's solution, we're making use of multiple inputs, right? If the inputs are all distinct, this function is going to work correctly, right? So the problem is when there are duplicates, and exactly where the duplicates are, you have to be a little bit careful, right? So I would like either Ayush or Shardul, whoever would like to talk about how you approach this problem, because your thought process was clearly very good. It led you quickly to a counterexample. Can you help us understand what helped you come up with these counterexamples? Can you try and think back to your thought process? Whoever would like to try and share, if you can raise your hand, and then maybe the organizers can unmute you. Meanwhile, Sumit Arya is saying it doesn't efficiently handle duplicates, right? We don't have to worry about efficiency right now. The code is wrong, right? So let's not get into efficiency. Absolutely, it's doing it slow, but the bigger problem is it's doing it wrong. So efficiency is something we should worry about only once we're sure that the code is correct. Okay, so of course your point might be, which is a very valid one, let's throw this code away anyway. It's very inefficient, right? So who cares if it's right or wrong? It's just inefficient. We wouldn't want it anyway, which is also a valid way of looking at it. I agree, but in general, we don't like throwing away code in industry too much. Somebody has written it, somebody has paid for it, and so on, right? So so firstly, we will throw away the code if it's wrong. We'll fix it if we can. Okay. But certainly the loops could have been written differently. Actually, there are much more efficient ways of counting the number of unique elements in an array of numbers, right? I'm sure you're familiar with an n-log-n algorithm. I'm sure you're familiar with a roughly linear algorithm if you use a clever data structure. Okay, these are standard interview questions that you're probably familiar with the algorithms for doing this. Okay, so I don't know if either Ayush or Vedant wanted to suggest that thought process. Shardul, rather. Vedanta said, I think it doesn't consider the repeated elements as one element. Okay, so let's try and see if we can unpack that, right? So what happens if there is a repeated element at some index I and some index j? So I is somewhere and then j is somewhere, and I assume I is not equal to j, right? So I is not equal to j and ai is equal to aj, then we will break out of this loop, right? J starts off at 0. So if we break out of the loop, j will not be equal to n, right? Normally, if we don't break out of the loop, j starts at 0 and j less than n, j plus plus, which means the loop will finish with j equal to n, right? So this means that if this condition is ever true and we break out early, that's when j will be, this condition, j equal to n, will be false. Right? If we break out early, then this condition will be false. Then we won't increase the count. So you can kind of see where the person who wrote this code was thinking, right? They say, hey, I found a duplicate. So then don't increase the count. Only increase the count if you don't find any duplicates, right? That seems to be the logic, right? And what Vedanta is suggesting is that this doesn't quite work. Ayush is saying j will be less than n if the code finds a duplicate value, but the code doesn't work on how many times this number has been repeated. Okay, I'm not totally sure I understand exactly what that last part meant, so maybe you can try and rephrase it. Okay, in any case, all of you have the link. I would like you to convince yourself why this code is incorrect, right? Eventually, if you want to fix the code, there are, I'm sure, better ways will come to you. Okay. See, for simple problems, there might be a very simple solution that is much easier than this complicated logic that's given. But in the real world, you will face code that looks ugly like this, but it's doing something complicated. And so it isn't going to be obvious to you, haha, that's how you should fix it, right? That code could have been written by a human being who used to work at the company before you. It could have been written by AI. And in both those cases, your ability to stare at that code, to critically analyze that code, to prove that it's incorrect before it breaks, before it crashes, is a very valuable ability. This is a skill that I think all institutions should help their students develop. The way I work on developing this skill with my students is through these refute problems. Okay. Lastly, I want to share just one thing with you. There is a conference that ACM India runs called ACM Compute. Right? This year, it's going to happen in a few days. It's happening in IIT Gandhinagar, right? And at this conference, and the conference happens in different places all over the country. This year, at this conference, one of the papers is something that I'm presenting on refute problems. I'm presenting two papers. This one, this is also on refute problems. This is an algorithm for auto-grading refute problems. Okay. The algorithm that I'm suggesting is a very naive one. It's mainly meant to be easy to explain to students. If any of you are interested, there is opportunities to develop more interesting, sophisticated algorithms. If you're interested in exploring this, one possibility is identify some of your faculty who could also be interested in this, and perhaps we can collaborate and explore this together. Okay. There are many other interesting papers that are going to be presented at this conference. So at some point, consider attending this conference. Some of the papers are, in fact, many of the papers are include undergraduate authors. So in this particular paper, which is by some of my students, all of them are undergraduate students, right? All of them have been subjected to refute problems, but they are doing something with LLMs in English, right? Maybe you can do a similar study in Marathi or a combination of Marathi and English. There are lots of interesting problems for you to consider. So consider exploring this space. So with that, I will end. We have a couple of minutes. If you have any questions, I'll be very happy to answer. Thank you. Yeah, okay. Shardul has a question, so could someone unmute him, please? Hanji Shardul, I think they've unmuted you.
Sir, there are some questions asked by the students.
Hanji.
The first one is, what are some easy ways to improve or clean up AI generated code?
This is a very interesting question. So, it depends on what we mean by the code being messed up in the first place. In my experience, a major problem is if you're using some, you're writing some problem specification and then you're using AI to produce the code. Many times the problem is with the specification. Like, when I said count digits, right, or count vowels, number of vowels, right, I wasn't being clear if I wanted to count distinct digits or distinct vowels, right? So sometimes the problem statement itself is not clear. And by the way, this problem is more severe in a linguistically diverse country like ours, right? The client might be a Bengali speaker. I'm a Marathi speaker, right? And we're communicating in English, right? So there is 3 languages going on over here, right? It's challenging to convey the right thing. And the client might be, a Chinese speaker or a Malaysian speaker or an American speaker. I mean, so the language could be, mixtures could be very complicated. So this is one issue, right? There are other issues, right, with related. As I said, syntax is very rarely the issue. There are other issues. Performance is one. If the code uses libraries and the libraries are being changed frequently, that is a problem. So the short answer to the very interesting question is it depends on the nature of the problem, right? There can be many types of different solutions, right? So it's unfortunately not a short answer, but there are, as I said, many types of issues. Okay? But good question, very important question.
Second question is, what are some good resources to learn about AI in detail?
So if it's about AI in general, there are tons and tons of excellent courses. Fast AI, I think, is one of the nicest courses that are out there. If it's about AI for code generation, the first thing I would suggest is please use it for code generation. I hope you're exploring it. Effective ways of prompting AI to produce code, and I don't mean prompt engineering. Okay, so you saw, for example, how in the demo I gave at the start, if I used things like useful function names, meaningful function names, meaningful argument names, meaningful type hinting, meaningful docstring, meaningful doc tests, then I get good code. Okay, or I can improve the quality of the code by doing these kinds of tweaking of the prompt. I call this technical prompting, not prompt engineering. Okay, so that is what I would look at. So again, I hope I wasn't totally sure what the intention of the questioner was, but I hope my answer covered something of what they were interested in. Kanisha has an interesting question on the chat. Exposure to writing code also develops the skill of finding errors. Yes, absolutely. The thing is that many of us get very comfortable with our own style of code. But the thing is, Kanisha, that most of the code you're going to see in your professional life is going to be written by others, right? Others now includes AI, but it also includes other human beings. So it's a very important skill to develop the ability to identify errors in others' code, right? I hope that makes sense. And that's really why we're going here.
Hello, sir. There is another question asked by the student.
Hanji.
Since you have studied statistics and computer science, how safe is the field of quant finance and applications of mathematics to choose?
I think it's very, very safe. There are a lot of interesting problems around that. There's a lot of money, quite obviously, in that space. I think jobs in that space will be quite secure. But the thing to keep in mind is, the skill set that you bring in. You say, I'm good. I have the right skill set for this job, right? I think one of the things that these advances in generative AI in particular are forcing us to think about is, what do we mean by the important skills, right? So as I said, if I said to you that my skill is to type the semicolons and the commas, etc., so in the context of quant or whatever it is, right? I can write the necessary code. Somebody just has to tell me what the problem is, and I can type the code and solve these fintech related issues or whatever it is, right? Or data science related or AI related or whatever. So I can write the necessary code, right? Well, unfortunately, my ability to write the semicolons and the commas is not the most critical skill today. So I have to take those fundas of mine and elevate them to a higher level, and I should be prepared to let the AI do the boring part. I have to start thinking of ideas at a higher level, right? So there is a very clear trend in programming, as I'm sure you're aware. Long ago, everybody used to program in zeros and ones. Then the big breakthrough, we'll type in assembly code. We won't have to type in zeros and ones. Then the even bigger breakthrough of compilers. That means you can think it a higher level language, and the compiler will convert that to lower level language for you. And now, in some sense, Gen AI is like taking it to an even higher level. The big difference is that unlike a compiler going down to assembly based on some rules that can be formally verified and checked, an LLM will convert, say, English into code not by rules, but by this potentially hallucinating LLM process, this transformer based process. And so you can't be so sure about it anymore. That's where all this refute business comes in. So I think we should, as I said, a very long way of saying that the space that the questioner has mentioned is very safe, but don't get too comfortable in, I know all the skills that are necessary, therefore my job is safe, right? The space is going to be rich, but you're constantly going to have this pressure to think at a higher and higher level, because there's going to be all kinds of tools to take care of the lower level stuff for you. That is just the nature of technology. So you have to be able to do abstract thinking significantly, right? That's a very, very important skill, and that applies in any space pretty much that our students go into, which is in computing, right? But yeah, that particular space is going to be fine for you.
Okay, sir. ठीक है, चले. Now I will hand over the session to continue with Khushi.
Okay.
He will
thanks.
give the vote of thanks.
All right. Thank you. I'll wait. Yeah.
Good evening, everyone. Thank you for being a part of this engaging and insightful session on helping students develop the ability to critique AI-generated code. Myself, Kushi Chakke, and on behalf of PASC, I extend my deepest gratitude to all of you for being here today. It has been an inspiring and enlightening session, especially having the privilege to hear from Professor Viraj Kumar. First and foremost, I would like to express our deepest thanks to Professor Viraj Kumar for sharing his invaluable insights, expertise, and passion for fostering critical thinking in AI code development. Your knowledge and perspective have truly illuminated the challenges and opportunities in this evolving field, inspiring us to approach AI not just as consumers but as thoughtful evaluators. I'd also like to express my sincere appreciation to the PAST team, Dr. Gitanjali Kare ma'am, for being a continuous pillar of support, and our organizers for making this event possible. Your dedication and effort ensured that the session was engaging, educational, and memorable. All the participants, thank you for your enthusiasm, questions, and active participation. Your energy made this event truly special. Let's take inspiration from today's session and continue pushing our boundaries in our respective fields. Once again, a big thank you to our guests, organizers, and everyone who joined us today. Wishing you all continued success and a wonderful day ahead. Thank you. I may now request everyone to turn on their cameras for a quick photo.
Thank you, Kushi, for that very kind wrap-up. And thank you to all of you. It's been really great. Great questions, and good to see people solving these problems so quickly. I was very impressed.
Thank you, everyone. Thank you, sir.
Thank you. Sure. Take care. Bye-bye.